Hello children, today's lecture is to solve numerical problems based on Coulomb's law. Means today you will be learning about the processes, the ways, the methods to solve numerical problems based on Coulomb's law, because you learned Coulomb's law in detail in previous lectures. So you see, this is Concepts of Physics Part 2 at C. Verma's book. I am solving the problem from this book. Exercises, it is in page number 121. You can have the book and look at the problem. So question number 2, you see question number 2 is there. A charge of 1 coulomb is placed at the top of your college building and another equal charge at the top of your house. Means you have two charges. One charge is at the top of your college and other charge is at the top of your house. Means the two charges are placed at certain distance. Take the separation between the two charges to be 2 kilometers. What does it mean? It means the distance between the two charges is 2 kilometers. So whenever you start solving the problem, at first you have to write the data in the form of symbols to be used in the formula. So you have to write given Q1 and Q2, both are equal in magnitude. So Q1 is equal to Q2 is equal to 1 coulomb. The distance between them is denoted by R. So R is equal to 2 kilometer. You can write it 2 into 10 power 3 meter. Means you must change all the given values in SI. After then, find the force exerted by the charges on each other. How many times of your weight is this force? So you have to find the force applied by the charges on each other. You know that the force on each charge will be equal. Why? Because this is the action-reaction forces. But one thing should be remembered, that suppose here is a charge Q1, 1 into 1 coulomb, and here is another charge 1 coulomb. The distance is 2 into 10 power 3 meter. So force on 1 coulomb due to this coulomb will be in this direction, and force on this 1 coulomb due to this coulomb will be in this direction. The reason is clear, that both are of same nature, so they will apply repulsive force on each other. One thing must be noted here, that the two forces are acting on two different charges. They are not acting on the same charge, so they will not cancel each other. Means there will be net force on each of the charges, but the net force on any of the charges is not zero. Is it clear? Now you have to use the formula. You have formula F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now you may ask that, why have we used epsilon naught? Can we use epsilon in place of epsilon naught here in the question? No. In this question, we have no information regarding the intervening medium. It means the intervening medium is taken as free space. So we will use 1 by 4 pi epsilon naught. If there will be information regarding the intervening medium, that is other than air, or that is some medium, not free space, then we will use epsilon in place of epsilon naught. Now substitute the values given here. 1 by 4 pi epsilon naught is 9 into 10 power 9 into Q1. This is 1 coulomb, Q2 1 coulomb by R 2 into 10 power 3 square. This will be 9 into 10 power 9 divided by square of 2 is 4 and the square of 10 power 3 is 10 power 6. So you can write it 9 by 4 into 10 power 9 minus 6, 3. Now if you will divide 9 by 4, what will you get? 2.25 into 10 power 3 Newton. So this is the force applied by each of the charges on other charge. Now you see we have not used the unit here. Means we have not used the unit of 1 by 4 pi epsilon naught here. What is its unit? You know its unit is Newton meter square per Coulomb square. But we have not written the unit here. Again charges are in Coulomb. So we have not written the units here. So you are suggested that please don't write the unit during the calculation. You just put the unit at the final answer. Means 2.25 into 10 power 3 Newton. As all the units are an SI and force is having SI unit Newton. So we have put here Newton with the answer. So this is the force. Now 2.25 into 10 power 3 Newton is this force and that is this force. Now another part of the question is how many times of your weight is this force? The question's another part, second part is that how many times this force is of your weight. So at first you write your weight is equal to, suppose you say that your weight is 50 kg. It doesn't mean that 50 kg is your weight, actually that is your mass. So if you tell that your weight is 50 kg, you convert it into Newton, means 50 kg into 9.8 because W is equal to mg. M is mass and g is acceleration due to gravity. So 50 into 9.8. If you will multiply it, you will get 490 Newton. Now you have to compare this 490 Newton with this weight. How many times of your weight is this force? Means therefore weight is 490 Newton and force is 2.25 into 10 power 3 Newton. Therefore required ratio is equal to 2.25 into 10 power 3 by 490. You solve this and this will be the answer. It will have no unit. You know it will have no unit because it is ratio of Newton. Is it clear? So this is the question number 2. Now just check it. After then, by learning question number 2, I want to solve question number 3. Question number 3, you see. Question number 3 of the same book. In question number 3, it is stated that 2 equal charges are placed at a separation of 1 meter. Again you have 2 equal charges. So you take given Q1 is equal to Q2. You can take them as Q. Say separation is 1 meter. So R is 1 meter. What should be the magnitude of the charges so that the force between them equals the weight of a 50 kg person? Means you are asked Q and F is given 50 kg weight. So you change this 50 kg weight into Newton. 50 into 9.8. This is 490 Newton. This is to be obtained. So again use Coulomb's law. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. You see this is 9 into 10 power 9. Q1 is Q, Q2 is also Q, by R is 1. So 1 into 1. And this F is 490. You have to find this Q. So keep Q left side. Q square is equal to 490 by 9 into 10 power 9. It will be 49 by 9 into 10 power minus 8. Now solve it to find Q. Square root of 49 by 9 into 10 power minus 4. So square root of 49 is 7 and the square root of 9 is 3 into 10 power minus 4. This is equal to 3 2 ja 6. 3 into 10 power minus 4 Coulomb. Means each charges are of this value. Again you see we have not written the units of different quantities during the calculation. We just have put the unit at the last. So this is the way to solve question. In question number 2 you obtained the value of F. In question number 3 you obtained the value of Q. Here F is already given. Now let us take another question. Question number 6. Question is two charges 2 into 10 power minus 4 Coulomb and 1 into 10 power minus 6 Coulomb. Two charges 2 into 10 power minus 6 Coulomb and 1 into 10 power minus 6 Coulomb are placed at a separation of 10 centimeter. Where should a third charge be placed such that it experiences no net force due to these charges? This is another kind of question. And one of the question like this is generally asked in board examinations. So you have Q1 and Q2 given. Q1 is equal to 2 into 10 power minus 6 Coulomb. Q2 is equal to 1 into 10 power minus 6 Coulomb. And R is given 10 centimeter. Now see the diagram. This is the position A and this is the position B. Here is Q1 2 into 10 power minus 6 Coulomb and here is Q2 1 into 10 power minus 6 Coulomb, and this is the distance. This distance is of 10 centimeter. Now you have to find the position of the third charge so that third charge experiences no net force due to these charges. This is related to principle of superposition. Now you can think that what are the possible positions at which the third charge can be placed. First position you can think between A and B. What will happen if the third charge will be placed between A and B? You see both of these are of similar nature. You don't have the nature of the third charge. Third charge can be of positive nature, means like these two charges, and third charge may be of negative nature, means opposite to the nature of these two charges. Let us take the third charge positive and its value as Q. Suppose it is placed here, Q, at a point P, at a distance x from A, means this is x, then this will be 10 minus x. One thing should be remembered here, that this x is in centimeter because this 10 is in centimeter. If you will change 10 centimeter into meter, then x will also be in meter. But it is easy to find x in centimeter because you have very small distance, 10 centimeter. So we will not change this in meter here. Is it clear? Now what will happen if P will be between A and B? Force on Q due to this charge will be repulsive because this is positive and this is also positive. So you can represent the direction of force here. This is force on the charge at P due to the charge at A, means FPA. Force on the charge at Q due to this charge. Again, these two are of similar nature. So the net force will be in this direction. This is FPB. Now you see the two forces acting on the same particle at P in opposite directions. You learnt in class 11 and you were also asked to revise vector. So you must have remembered that two vectors in opposite directions can cancel their effects. Means net force at P can be 0. It is the possibility. If both of these are of equal magnitude. Otherwise, the net force on P will not be 0. So in question, you have to find the position where the net force is 0. So these two should be equal in magnitude. So for the net force at P to be 0, that is FPA plus FPB is equal to 0. You can write FPA is equal to FPB. You see, we have not used arrow sign here because here if you will put arrow sign, then this will be negative. But we are talking about the magnitude, so this FPA is equal to FPB. Now what will be the value of FPA? This is 1 by 4 pi epsilon naught. Q1, you take this as Q1, 2 into 10 power minus 6. Q2, Q divided by R, means this X. As this X is in centimeter, so you convert it into meter. X into 10 power minus 2. It is equal to 1 by 4 pi epsilon naught. 1 into 10 power minus 6 into Q by 10 minus X squared into 10 power minus 2 squared. Again we have changed it into meter. You see these 1 by 4 pi epsilon naught can be cancelled out from both the sides. This 10 power minus 6 can also be cancelled out from both the sides. Q can also be cancelled out from both the sides. 10 power minus 2 square can also be cancelled out from both the sides. So finally, what will you have? You will have two by x square. It is equal to 1 by 10 minus x whole square. It is 2 10 minus x whole square is equal to x square. Now, there are two options to solve this question. One, you can square this 10 minus x by expanding on the basis of a plus b whole square. But if you will expand it by using the formula a plus b whole square, it will be difficult to find. So you are asked to remember, that if you have this type of question, you must take a square root on both the sides. Don't expand it. You must take the square root on both the sides. So taking a square root on both the sides, you will get root 2. This is 10 minus x. This is equal to x. What will you get then? This is 10 root 2 minus root 2x. This is equal to x. So 10 root 2 is equal to root 2 plus 1 into x. It means x is equal to 10 root 2 by root 2 plus 1. It is 10 into 1.414 divided by 1.414 plus 1 means 14.14 divided by 2.414. And if you will solve this, this will be the answer. So this is in centimeter. And this distance is from A. This distance is from A. Is it clear? From B, you have to subtract this value from 10 centimeter. That will be the answer. Have you got? Okay. Now we can come to another question. If you solve it, then you can get it 5.9 centimeter. This is the answer. Now one thing I want to inform you, or I want to clear you, that if the question is of objective type, means you have multiple choice question, then how can you solve it? You see, this will be cancelled out. Q will be cancelled out. So you just write this step, means this step. You have to start with this step and find the final answer. So by this way you can solve the question if it is asked for multiple choice. Now let us discuss another aspect. As you were having 2 into 10 power minus 6 Coulomb and 1 into 10 power minus 6 Coulomb, what will happen? If one of these two is negative, suppose this is negative, you can have question like that, that this is negative or this is negative and this will be positive. Means the two given charges are of different natures. They are not of same nature, placed at certain distance apart. Then where should be the third charge? You see, if both are of same nature, whether they are negative or they are positive, you have to put the third charge in between A and B. Now if you will put the third charge in this case here, then what will happen? P. Suppose this is positive. So this charge will repel Q and this charge will attract Q. Means both the forces acting on the particle Q at P are in the same direction. And you know that if two forces will act on a particle in the same direction, net force can never be zero. What will happen? If both are negative, then the force on Q due to this is in this direction and force on Q due to this is in this direction. So again the net force can be zero. Means one thing should be remembered here, that if both the given charges are of same nature, the third charge, whatever be its nature, must be placed at a point in between A and B to have net force 0. If they are of opposite nature, then what should we do? You see, this is negative and this is positive. Now another option is that in this direction or this direction you can place the charge. In this direction and in this direction you can place the charge. So if you place the charge, third charge here, then what will happen? This particle will attract in this direction and this particle will repel in this direction. If you will place the third charge here, This will attract in this direction and this will repel in this direction. So you see, the sum of these two forces will never be zero. Why? Because if you have two vectors, the resultant of two vectors can be zero if and only if they are in the opposite direction. So otherwise their sum will never be zero. Okay. So these two positions are not fit to have the third charge. Now how other positions can be taken care? So if we take the third charge here, what will happen? This will attract the third charge in this direction and this will repel the third charge in this direction. So again the two forces can be in the opposite direction and there is the possibility to have net force 0. If you will place third charge here, then this will repel in this direction and this will attract in this direction. Means here F PA and this is F PB, and at this position this is F PB, F PA and this is F PB. Now you have two options where the net force can be 0. Now which one should be taken care? So you know F is directly proportional to Q1 Q2 by R squared. So you have to check Q1 Q2. You see this is a smaller one and this is greater one. So product of Q and this will be less than the product of Q and this. So Q1 Q2 will be less for the smaller charge and Q1 Q2 will be more for the greater charge. If numerator is more and denominator is more, numerator is less and denominator is less, only then two fractions will be equal. So if Q1 Q2 is small, R should be small, means the third charge must be placed nearby the smaller charge smaller charge given in the question. Is it clear? Okay. So this was the another type of question to be discussed. Now question number 8. Two charged particles are placed at a distance 1 centimeter apart. Two charged particles are placed at 1 centimeter apart. What is the minimum possible magnitude of the electric force acting on each charge? पूछ रहा है, sorry. It is asked that what is the minimum possible force acting between the two charges. So you have to know what can be the minimum possible charge. So you know the minimum possible charge is the charge on an electron or charge on a proton. E is the minimum possible charge. So if it is E, the force will be minimum because we cannot have the charge smaller than E, and E is equal to 1.6 into 10 power minus 19 Coulomb. So the minimum possible charge F is equal to 1.6 into 10 power minus 19 Coulomb is the minimum possible charge. F is 1 by 4 pi epsilon naught Q1 Q2 by R squared. This is 9 into 10 power 9. Q1 is 1.6 into 10 power minus 19. Q2 is 1.6 into 10 power minus 19 and divided by R is 1 centimeter. 1 centimeter can be changed into meter. So 1 into 10 power minus 2 meter. This is 9 into 1.6 into 1.6 will be 2.56 into 10 power. See, 19 into 19 minus 19. So minus 19 plus 9. And this will be minus 4. Whenever it will come to the numerator, it will become plus 4. Now multiply these two. 9 6 are 54. 4 50. So 23.04 into 10 power minus 38 plus 13. This is 23.04 into 10 power minus 25. We can write it 2.304 into 10 power minus 20. Five plus 1. So this is 2.304 into 10 power minus 24 Newton. This is the minimum force that can act between the two particles. Pause.